Welcome to the NewSpace India podcast, a bi-weekly talk show that brings you exclusive stories from people driving India's space activities. The NewSpace India podcast is pleased to announce our association with Dassault Systems, a global leader in providing businesses and people with collaborative virtual environments to imagine sustainable innovations. Dassault Systems solutions support startups, small and medium-scale enterprises, and original equipment manufacturers in developing disruptive solutions for space launchers and satellite propulsion. Hi, and welcome to yet another episode of the NewSpace India podcast. And today we have the team from SkySERVE, Aditya and Vishesh here, who are going to be talking about the technology that they are building and the new company that they have. Hi, Vishesh and Aditya, welcome to the show.
Thanks for having us, NP.
Before we get into SkySERVE, would love to know each one of your backgrounds and what got you together to build SkySERVE.
Sure. So maybe I can start. So I have a background in as a bachelor's in aerospace engineering. So I studied from IT Kanpur, batch of 2011. 2013 onwards, I joined Team Indus. It sounded one of the most exciting opportunities around, and it turned out to be the same. And initially, I joined in for basically starting with lunar descent. That was the primary problem that we were trying to solve, and slowly matured into the role of the guidance, navigation, control role. So this involved me and our team to essentially write the requirements for the GNC system that we are building for the lunar lander, write it from scratch, build the algorithms, test them on hardware as well. So we went through the full cycle, so in-loop testing and rehearsals and so on. Around 2019, when we found that for reasons beyond our control, we had to, especially I as well, had to leave TI, and we started ideating on new future-looking technologies that we could build. And that's when the idea for SkySERVE came around, and we incorporated in 2020. And we have been working on developing this idea from that point onwards. So, that's about it from me.
Hi, NP. Thanks, Vishesh, and thanks for having us. So my background is pretty similar. So as an aerospace engineer, a year younger than Vishesh, so I have a little more hair. So I sort of wanted to know more about space-related subjects, and unfortunately, most of the courses in India don't cover that, and that actually got my sort of hunger to learn more about how do you build spacecraft. It's mostly concentrating on aircraft and all the sort of intra-atmospheric craft in India. And when you have that void, then you want to know what's more, what's out there. So that's when I thought, let's go learn about space. I went out to the UK and studied specifically space engineering, and that opened up a huge sector to me, which I didn't know really existed. All I knew was there's ISRO, and they do launches, and you can see them on DD. And beyond that, there's probably something. So my uncle worked at ISRO, and that's actually how I knew that ISRO as an entity itself existed. So that combined with the dearth of information, I thought, let's go investigate this. And I think after I completed the master's, I applied to quite a few jobs, and finally saw that there's a company back home in my own hometown in Bangalore, which is doing something really interesting. So I joined Team Indus, met Vishesh for the first time there. I think that was in 2013, somewhere in the end of 2013. And I sort of got an opportunity to try out different teams. So started, I think, with power systems, and then moved to mission operations, and finally, Vishesh and I got to head the systems engineering group. And that was like quite fun to see different complex groups working towards the same goal. And my real interest was always in operating spacecraft, and that translated into wanting to know what can you do better. Why do you really have to depend on people on the ground to get stuff done in space? Because everything is there in space, but just the intelligence is not there. So you're still depending on ground for that. So that contributed a little to the stuff that we were discussing. Vishesh, Vinay, our third co-founder, and me. So what can we put all our interests into, and what's that set of problems that can be solved? So that's where SkyServe came up. I think before SkyServe, we didn't, as in the name came a little later. We were calling it, say, space edge, orbit edge, edge compute, different variations of the same thing. But then we like, let's remove the technology from what we're talking about and named it SkyServe. So yeah, that's where we are at, and it's been at least, I think, almost 2 years since we started that thought, and we've come quite a way.
Yeah, absolutely. Thank you for that. It's always interesting to see that there's like multiple companies that I know that have come out of people who were involved in Team Indus. There is Nakul, who's doing cell propulsion, and there is Astrogate Labs, that's come out doing laser communication, and there's you guys that are now doing this, and there's also this NewSpace research guys who are doing more the UAV things that are there as well. So I mean, an interesting mix of people trying to break off and trying to do new entrepreneurial ideas. That is always kind of interesting. And as you said, there's multiple things that you could have done at the end. Why do you think that you chose this edge computing kind of a space at this point of time?
Yeah, I'll hazard an answer. So I think it's probably a combination of the personalities and our experiences. So Vishesh is deep into algorithms and autonomy, and my interest was how do you get sort of nights out operation, but for mission focused satellite. So if you're talking about any application of a satellite, then how do you go about that? So if you see, communication constellations have to be autonomous because their position actually doesn't determine what the main payload is. It may be above the poles, it may be above the UK, above the Pacific Ocean. It's either an on or an off of the payload, but there's no other context to where it is flying above. So that autonomy coming in to know what exactly is the context of where you are, what you have to do. So I think that's a very interesting problem to solve, and now that many companies are coming forward and being known publicly, I think a lot of the news out there, which has brought mainstream investors to look at a company like Planet. Some of these pieces of news basically are educating people that these things are real. So previously they thought, yeah, DTH is satellite. I point my antenna there, I'll get ZTV. So now it's probably a new trend that probably people who are outside our industry start noticing. So that's actually an interesting place where we find ourselves, that all this technology that we're building, can we directly go to the people and service them? Like DTH is literally bringing the goodness of satellites directly to the house. And could you do that for Earth observation was one of the questions that we were discussing. But then also we iterated on a different. It went. I think Vishesh had this inspiration that can you get an end consumer to appreciate Earth observation? As I'm stealing his point though, but which is that emotion of the end consumer that Earth observation automated, directly served to that person's, say, laptop, computer, mobile phone, would be so satisfying that they would want it all the time. So we went all the way from that end to where we are today. And I think we will ultimately be able to get to that point where an end consumer could probably appreciate this, mainly because we are trying to simplify it and also bring some technologies that can make that jump possible. Because like emotion, desire to have something is one, but if you can't afford it, then you either need to wait for the next generation to come, because the cost reduction certainly takes time, or you need to basically be having a much higher purchasing power. So these sorts of were the thoughts that we had. How do you break it down to people? How do you make an impact directly to the consumer? And we chose quite a few steps, both technical as well as business, that could get us there. So it's a quite a set of milestones we've put out. I think some of it is a little defined, some of it is a little more fuzzy, some of it we'll discover as we go. So yeah, that's sort of the background thinking.
Yeah. So one more thing I would like to add is that we also noticed that edge computing itself is kind of an underexploited technology in space. And we had been reading about that, okay, there are ideas there. And the kind of computers that we have commercially available at everybody's place, it just seemed obvious that if we allow edge intelligence to be more prominent, some of the key constraints that are stopping Earth observation to be more ubiquitous could be done away with. So this is something that then, I mean, just thinking about the problem statement, we obviously did our literature survey. We found out that this is something that has not been really risked by, so to say, traditional space operators to have high-end computing. So the computing is meant to do something very specific for each mission and each satellite platform. So that prompted us to think more about that point of view, that say, if there was more intelligence and more computing power that these edge computing devices had, what else could we really do? So that prompted us in this direction.
Great. And for the audience sake, it'll be very interesting to know, what is edge computing and how is it different from other kinds of computing?
So yeah, there would be two types of computing. So centralized and decentralized. So centralized would involve, a big fat server, or say, a high-end computing device at one single place. And edge systems require the similar kind of compute to be distributed and situationally, as in or positionally, separate places. So what edge computing allows you to do is reduce the time till which a computation happens. So if there's a huge sensor stream that is filling a centralized computer with all this information that needs to be analyzed, obviously it will have its own benefits and demerits. But yeah, so these are two different ways of thinking about it. So in edge computing allows you to do a very decent amount of compute at the edge, which is closer to the source of the sensor that you're essentially operating on.
Right. And what would be the end user benefits in all of this compared to traditional Earth observation? So if you could explain that with, let's say, an ISRO system that perhaps, for example, ISRO uses as a legacy solution.
Yeah, I think one way to look at it is, and we went through quite a few paper runs of this. So just to put into context, we actually picked up Cartosat 3 and assessed that for the downlink speeds that they have, the volume that they could get down, and the dedicated ground stations that they claim is for them to take these data products. So from that, what you see is they're using probably maybe 10% of their total image capturing capacity, because that's all that they can dump down to the ground, and that's what becomes a product. and Cartosat 3 is largely tasked because it's high resolution. So you really can't keep collecting images of locations that you don't have an immediate need for, because then you run the risk of, there's an immediate demand, say for any specific purpose. Say there's a demand that comes from a government agency, they have to respond as soon as they can, and they can't have capacity already taken up. So one key here is that you have to plan this out so carefully that you will never end up utilizing the rest 90% of the image capturing capacity on the same satellite. And that's a lot of maybe for the Indian government, it's not exactly a criteria, but if you look at it in commercial terms, you are really not uh, extracting as much as you can from that same asset. So, in that sense, what you could do here is, if you were to compute only that which is required, and even areas that you need to observe, say, if it is optical and you really don't have a use for, say, cloud covered regions during monsoon, you don't need to try to take those images and then see, okay, hit and miss, like probably I will get something in between the clouds. You don't need to do that, because then the intelligence can be closer to where these images are being created, and you can avoid those downlinks, but also it opens up all that rest of the spare capacity for you to capture information. So one way to try that out is speculatively take images, and if they are needed, bring them down, and the criteria for that can be user defined. And that's a little bit of intelligence, but that's not really the full scope of what we're thinking of doing. But something as basic as that could really get more out of the same asset, the same initial investment, and probably even reduce the manpower cost to maintain, say, a Cartosat 3 operation. So that's one paper run that we tried. There's of course, if you scale this up to, say, a constellation level for most of the small satellite operators today, uh, per day saving, say you are scheduling probably one commanding pass per satellite. If you were to eliminate at least 20% of these commanding passes, so say you take a satellite constellation with 100 satellites, 20 commanding passes eliminated, uh, that's a huge savings, not just in ground station time, but it's also a saving in terms of the people there, because they could do a lot more work. And a lot of these operation centers today don't just have operators, they're doing a lot more tasks. They're also probably helping out in payload scheduling, maintenance, trying to fix anomalies. So this frees them up a lot more. So it's not just in terms of utilizing the asset well, it's also freeing up and probably having a smaller, more agile team on the ground.
Right. And Vishesh, do you have anything to add there that is kind of complementary?
Yeah, so I could also give you an example of a use case here. So uh, I'll give you two options. So there's a fire near your house, and option one is that the fire is seen by someone remotely, and somebody that person relays it to another person. In a matter of 2 days, you get to know, okay, there's a fire around my house, and that third person tells me this. Uh, the time that it takes, the fire has already probably engulfed your house, and you know about it, right? So clearly, the second option is that someone situated remotely immediately recognize there's a fire, and rather than depending on a third person who uh, who you basically give this information, allow him to interpret, you allow this observer to do this interpretation for himself or herself and directly tell you, reducing this whole long chain of information flow, and directly tell you there's a fire in your house as soon as possible, right? So this is something, then an edge computing use case, it can enable you. And that's the major benefit, right? So all of the things that you traditionally do, if I just take the example here, so images are taken, they're pre-processed and analyzed, and then an insight could be given to an end user. By this time, things may have progressed for the worse. So this is something that I'm giving a more extreme, more near real-time use case of what it can enable, but at least it gives you a sense to see the capacity and capability of this technology.
One of the things that people are trying to now achieve is kind of getting more quality data out and making satellite intelligence, right? So one of the things that I have seen people say is that almost 95% of the satellite data that people collect in Earth observation is pretty useless, because they're either with clouds or they're not features that people want to use as end users or other things that are out there. And there's a tremendous amount of people trying to build intelligence into satellites so that the use case for them and the whole cost in taking that data down is also going to reduce over time, and the use case is becoming more and more interesting, because you can then optimize when you operate that particular asset in space as well. Is this a movement that is primarily private sector driven, or is there also a thought process within ISRO or other space agencies, like ISRO, for example, or perhaps even within ISRO, to think on any of these lines? Or
yeah, I think I have seen plenty of examples in which, generally forward-looking technologies begin with space agencies. So, say for example, on the point of autonomy, NASA actually carried an autonomous mission in early 2000s, and so I think it's called EO1, where they did experiment with this. Now, currently, I would say it's a mix of both. Both space agencies are looking into it. For sure, the benefits are real, and the benefits are there from the cost point of view and the insights that they get from the images, as in cost and latency both. And clearly, private companies who are planning to do constellation, it's another aspect itself, in which you're not doing a limited science mission, but you are doing it commercially. So I have noticed that both ends have actually made some progress in this domain.
And I think it's also the nature of the sensor that they're using. So if you see, like most governments, at least they're interested in strategic applications for this. So I think you might see the space-based infrared system that the US had built, which is for near real-time missile warning. These guys, they were actually doing this. This is edge computing of a different type, because the sensing is so easy. So you see a hotspot, you just have to track whether the hotspot moves too fast to be a land vehicle, and you know what it is. So the signature is very apparent. Signal processing on board is straightforward, but that is sort of the very early example of computing on board and giving a ready-made product for somebody. Probably there's just the minimal part of doing a few coordinate frame transformations. That's all that may need to be done on the ground, and that could be done on somebody's terminal on the ground. So I think that's probably the true beginning of this sort of Earth observation, real-time computing in a government agency. But I think it's gone from those sort of simple data sets to more complex ones. So what Vishesh was mentioning, EO1, that was a hyperspectral sensor. And it really makes sense to try and find a way to reduce the cost of bringing that data down, because you really can't afford to bring, say, 500 bands of information, which is like probably 4 to 5 gigabits of data down for large enough areas. Like, you really can't have any useful data set. And the way that mission did it, it's still giving data sets for people who want to do crop classification for large tracts of land on Earth. They're still going to that data. But they had a budget. They couldn't have done it without some sort of autonomy. So their budget probably made them think in that direction. But that sort of has become the frontier or starting point for many people to say, okay, Earth observation that I can understand using autonomy in space. That probably was the starting point. And I think most space agencies are working on it. I think a lot of them would be bringing it out in steps, like say technology demonstration, say for the next Earth observation fleet, even in ISRO, certainly will have some parts of it. So, and I think we will know that once the products start coming out. If you see there's more volume being put out, probably this is the reason. And we won't know it. ISRO being ISRO, we will know it when it happens. A lot of them have to consider it because you have to be competitive, and again, resources are scarce.
And one of the things when you come to do all of these things is, what is a technology push versus a market pull? Is the most interesting question to ask in any of these technologies and the end user demand. Have you got a sense of what would be like the savings for an end user in all of this? Because often this technology, I can see this as a potential technology that the military will use in any case, because this is something that will help them detect a lot of the features and model aircraft and model certain features that will tell them where to look at changes immediately. That's the first thing that comes to my mind, or to anybody's mind in that sense, when you deal with all of these things. But then for this to really proliferate at the end, you would want to prove that the business case is really that the cost of doing business in this way and using this technology is much more attractive than cost of using the traditional system and having to download everything and having servers and having compute and having delivery of all of this to reduce all the noise, right? So I really haven't seen anybody like model this in a way that is consumable to anybody within the industry, or could also give a sense of what that would be like at the end. Do you have a sense of any of these?
Sure, I think some modeling, of course, we did. Wouldn't want to claim that we've got the best model and best understanding, but from what we uh, uh, inferred from that is, at one extreme, you could bring down uh, the cost of information that you need from an image, at least say by one order of magnitude. That's certainly possible, and this is purely by taking say ground station time into consideration. This is not anything else. But what is it that actually brings this down is the nature of what that information is. So if you're looking for change, no change, then the question is, who will be ready to pay for just a Boolean answer? And in order to trust a Boolean answer, they would want you to give them images for proof. So you would still need to spend for selling them that benefit, that you can bring down your cost uh, by an order of magnitude. But in order to convince yourself, you will still want to spend a little bit more, get convinced, and then the reliability will speak for itself, and then you will switch. So till you switch, we will of course have to support them, and the nature of what they want is going to define this true reduction. Because more than a cost reduction, it's value that shouldn't get compromised. So you're looking for the same quality that you probably got when you say looked at free Sentinel data. You were able to see change. You purchased, say, commercial imagery at a high resolution, you were able to see change. Now, this service is also able to give me the change, but it's giving me at something called a compromise, right? So it's not giving me what I used to get, but it's giving me exactly what I want. And that's a behavioral thing that needs to change. And some of the pilots that we've done actually brought that out. They still want proof. So you will take some time to convince and take some time for them to move. But what we've seen is those in the space industry are more ready to change. So they know exactly what they're looking for, and it's sort of test vectors, right? So if you have the test vectors and your system works out, you're always going to be able to replicate this cause and effect. So if this happened, this is my Boolean yes or no. If this is there, I can quantify it as so many objects detected, or this is the cultivable area in a farm. So they're already aware of that. But if you see, this order of magnitude reduction actually attracts far more new players, and that's the real market that most of these autonomy companies should be after, because cost reduction for incumbents who are purchasing data is sort of I think a very small portion of the market. So what we're seeing is this is sort of hoping to go mass market in a way. It's probably these technologies that will convince existing, say, geospatial companies to adopt this, and as they start getting convinced of this, that real one order of magnitude cost reduction will be unlocked to everybody else. Because say ISRO says I have images, and this tells that the say number of uh, uh, how do you say thatched roof houses have reduced over the last 1 year, and they give some metric. uh, Everybody is very eager to go check out the actual satellite image if they have used Google Earth and try to compare, is this really true? But if say the Indian government were to tell it has changed, and they used say SkyServe's technology, how do you convince the common man that this really happened? So these are places that I think it's a little bit of behavior change and getting used to a new technology. But from our models, what we see is both cost and latency are the main levers. So value has to remain a constant. If you can bring down the latency, people are ready to pay far more. They probably would pay more than the actual cost of the image if you can deliver it quickly, which is what edge computing has. And on the other side, if you can bring down the cost purely because of, say, the data volume, you have a different end of the market.
Great, great. And as I see it, you have to deal with two phenomena. One is, of course, if you want to build your own, GPU-based stuff, or you want to build your own hardware stack and mix that with your software algorithms at the end. How mature is the Indian ecosystem for you to get access to any of these hardware to put together anything of that nature? Because I'm sure that the software element is then driven by the hardware itself, and that's something that you can control much more than the hardware itself. I mean, how do you have any bottlenecks in this regard, or is it the playing field kind of very open, or you're looking at architectures where something that is very new into the space industry, it has never been brought together and tested, this can be prepared for the environment in space, and then you're basing it on top of that? Or
Yeah, so some of the stuff is going to be new, because at least in the Indian ecosystem, most of the space hardware is heritage, and it's been established for quite a while. So what we're bringing in is, of course, something that's not built for space, and we are actually quite fluid. So we're not basing our solution on any specific hardware. Our true offering is actually the autonomy stack. So it starts with one piece of hardware that we are going to fly, and as we go, whichever is the next best thing, or whichever suits say the support infrastructure, like which is the satellite platform that you're flying on, which is the sensor that you're taking inputs from. If you need to change, we will change. So if we're starting, say, with optical data, the number of bands, the bit depth, these are parameters that define how much is the throughput we need. So we're starting from a given point, and we will keep moving upwards and probably get a little more ambitious in the amount of compute that might go on board. So in terms of the ecosystem itself, I think it's quite a great ecosystem. So at least from our experience when we were at Team Indus, so a lot of the ecosystem was developed by ISRO. So even though they don't necessarily have their own products out, but they give great quality, and they really know what they need to deliver. And some of the ecosystem is also developed by Team Indus. So we tap into both these groups, and some very new players are also coming up. And I think this is the sort of second wave of interest. So there's a lot of ecosystem that's getting created by the launch vehicle startups out of India, satellite startups in India, so Dhruva Space, Pixel. So this sort of mixed ecosystem, I think, is you're always going to get one new player every month. I feel that's the way we are we are seeing this, and I think that is really great. Uh, yeah, as in this is on the hardware side, and I think software. I think it's a good place to be in Bangalore, at least to start off with, Vishesh.
Yeah, absolutely. I think on both end, I think we have. I think we're pleasantly surprised by so much the depth of knowledge that people have. Obviously, there are some things that we are. I mean, if it was everything was settled science and settled technology, probably we'll be too late for it. So we're obviously taking our risks on the technology. But yeah, so we will have on the software end some really good folks in India, and so in fact on the overall software autonomy end, I feel pretty confident that we'll have a very good start.
Yeah, I mean, this is definitely an interesting evolution of the Indian ecosystem. I've created a list of about 50 companies actually in the last 3-4 years that are very interesting, are using space in one form or the other. Mostly downstream. I think the press really focuses on the upstream a lot, unfortunately, and I've actually seen a tremendous amount of value actually created in the downstream by very interesting different use cases that are up and coming in many of these different segments. But unfortunately, the press doesn't really cover a lot of that in that sense. How hard is it for you guys to tap into customers? Because at the end of the day, ISRO doesn't really have a methodology to engage with startups to give out contracts, for any kind of these kinds of experiments in plugging into their own ecosystem of how they, consume and process data at the end. And I mean, today there's probably just Pixel, who is based in India, who's doing anything in remote sensing, or at least has something to fund with to begin with at in that level. So most of the people that you are then have to talk to are all abroad, outside of India mostly, right, as your potential customer base. Is it then easier to talk to a lot of these people? Is it difficult? Is it is there any bias?
Yeah. So in terms of so I spoke about two varieties of these users, right? So one variety, of course, is the one that already knows the products that we're going to give them. So they're aware of what is satellite sensor data. So they're already using multiple forms of that, and almost all of them are depending on commercial sources, in addition to, of course, tapping into ISR if they're able to get the data sets. So finally, for sheer scale, everyone starts at, say, Sentinel, Landsat, and many of these European and American EO programs. So the data sets that they have started with are how do you call the benchmark. So when you communicate with them, you start with that. So if you're able to deliver on any use case that they're working on using Sentinel, it's visible. So in their product itself, on their website, you will know they're using Sentinel data because they're giving land cover, land use change. They're giving agricultural use cases. So some of that is good enough information for us to know this is where they're going, this is what they are offering. And what we are working with is slightly improved resolutions to that, which means the cost there should be some element of cost. So if it's better than Sentinel, which is free and open thanks to the ESA's Copernicus policy, but anything better resolution than that probably needs to be purchased by you. So the closest that popular names that come up, say, is Planet, which is giving something close to 4 meters per pixel. That costs X dollars. So it may not be fully transparent, but it does cost something. So all you're trying to do is, if you can offer something that costs less than what Planet can give, but not give the image itself, is that attractive to, say, customer A in India, customer B in Europe, somebody else in Australia? So if you just place these geographies, you get to know what actually is their worry. So say in India, you don't have volume yet within India. So if you have, say, a farm aggregator or a retail chain as your customer, you don't have much volume to justify, which means you really need a different price point from a customer in Europe or in Australia. So in Australia, a single customer could actually give you that volume. In Europe, probably you need to go closer to a government player to get that, but it's easier to get in there. So these three different approaches is what we've seen to speak to customers. So you need to take your time to understand where they are, what they're already working with, and where in that problem that they're trying to solve is one of our two dimensions actually going to come in. So are they looking for cost reduction, or is it latency? And of course, value has to remain the same. So we're trying to remove some of the friction and complexity, but some of these guys already know some of this, right? So they already know how to process some of the data sets. So that's the first group, and this is what we've noticed, that it's very geography specific, and you need to get into the psyche of their user base to understand that. And of course, the second group is quite easy to understand that it is a hard problem to solve. So what you're going to see is that there are probably more companies that want to consume the final result outside India. So you're certainly not looking at India to be your first end user in quite some time. So these are all outside, and each of them think differently. So we came across a use case for smart mobility. I think Vishesh was working with them, and those guys like threw crazy problem statements asking, could you do this? So and some of the questions are like, they're very interesting, you want to solve them, but then you also tell them that you probably could solve it without satellite data, and you're trying to be honest to them because you don't want to misrepresent the Earth observation sector by, say, telling you could solve anything and everything from space. So some of these experiences have also been there, where we go out of our way to make them know what can be done and also what can't be done, so that we push them closer to solving real problems that we can also associate our name with.
Also, I mean, talking about the customers themselves, I one of the most mature conversations that we have had is with an Indian customer. So it's not that they are not there, and in fact, they have been very open, and this is something that I feel that's a very positive sign, that everybody's seeing the value, even the Indian analysis companies.
Yeah, I mean, always interesting as well, and there could be some other evolution that is coming up as well, and I'll try to also see if I can connect you guys to the Azista BST venture. I mean, we've been working with them for a while now, and the factory is almost ready now for them as well, and they plan to roll out the ability to have about 250 satellites built in Ahmedabad soon. And they have a number of end users that are looking at using that kind of capacity, and maybe having a local solution for some of the processing side might help some of these guys as well. And I'll probably take that forward and see if I can introduce you guys to them and see if that could be kind of be helpful as well. So apart from all of these things, the other aspect here is then it's very clear that you're looking to be like more commercial and trying to be like get yourself into positions where you work with other businesses at the end, and more of being a, if not local ecosystem is quite large, there's of course a global ecosystem of customers that you can tap into and get them on board. So I mean, this is one of the features that I like of Indian startups nowadays, because most Indian startups know that they cannot get the government as their customer, unlike the US ones or the European ones. So it forces them to have this cockroach mentality a little bit, where you think about how can I actually survive to stay in business working with other businesses, rather than let me just go lobby the US government or three-letter agencies or European Union or the European Commission to get some money off of them. I think this is one of the most interesting things for me in India, because you might have lower number of companies, but the quality of the companies, if they survive for like 3 or 4 years, will be much higher, and the ability to like scale as a bigger company will be much higher, because the foundations of every company will be commercial. I don't know what you guys think about it.
I would say totally, as in by most of your points here, that the trends that are, I mean, some of the Indian startups are surely by the ambition. I think, I mean, they are spawning off new ideas and new technologies here. For sure, I think. Uh, uh, Coming from the government point of view, I think there is probably talks more to the maturity of the ecosystem itself. Uh, Younger ecosystems will have in where say the space economy is just opening up, might have the space operator, traditional government space operator, uh, having some hesitancy in accepting more aggressive, ambitious startups to come join and participate there. Uh, in more mature ecosystems, we have found that there is more openness. For sure, that's the case. And uh, also from the technology point of view, I've seen that the Indian, uh, particularly about the quality, as you mentioned, some of the work that these companies are doing are probably amongst the top 3-4 companies who are really attempting to replicate or build similar technologies on in their own geographies. So this is also very inspiring to see. So we are not just making run-of-the-mill satellite platforms or CubeSats. We are making much more than that. So I would say that yes, all the trends are in a very, very good, encouraging direction.
Aditya, you want to add anything there?
I buy most of it, though I think newer ecosystems, I think uh, a success story probably is yet to come out, but I've seen a very new ecosystem, which is the Australian space ecosystem. It's much younger than India. They've been trying to be very open upfront, but yeah, the success story is yet to come out. So they've had a few launch vehicle companies. We're still yet to see a launch. They are incubating quite a few innovative companies from across the world. They've tried to bring them in, but I think that's a place where the first mover, every startup is looking for somebody to actually go lead the charge, and some places they're probably looking for a commercial player to lead the charge. So say if a Lockheed could come into Australia and lead the charge, people will be like, yes, now we know it will work. But in India, you already know that there is somebody already leading the charge. You just have to do your bit. So I think it's a mixture of different types of ideologies. So in Asia, at least, there's a very big example that we see right in our neighboring country. So they literally have told, please take maybe not the mantle, but take the charge to scare everyone away from doing commercial space. So if we just look across the Himalayas there and take inspiration, I think there's enough material there to push ahead. While I think the more mature ecosystems, I agree with what you say, that it gives a false sense of security, and also the funding ecosystems are really as in they're ready to err on the side of putting more, while you sort of learn your way to get your first check in India by really justifying, like, if I were to give you, say, 100 rupees, tell me that you could get more out of it than the other guy whom I could give you 100 rupees for. So you really have to break it down for yourself, convince yourself that yeah, I am worth this 100 rupee check. But a lot of people in these more mature ecosystems don't even think twice, as in they given probably 2-3 checks of 100 and told, do that you're already doing. I don't know what you're doing, but do it. So I think, yeah, it sort of teaches us a bit of that, and probably culturally also in India, I think we try to justify things a little more. So probably we end up becoming a little more competitive when we're on the market.
Yeah, I feel that I mean, on a slightly zoomed out picture, Indians are in the process of getting rich. So when we have that mentality that, okay, I can throw away some money, there's more risk-taking ability that would immediately be visible.
Yeah, and I think, Australia, I would say for me is not a great comparison to India, because the space agency is pumping a lot of money into the ecosystem, and I actually know zero Australian companies that do almost anything commercial. They almost all survive on government money, where the government is looking at establishing sovereign space capability, and they are basically funding these companies to stay alive. So there is no interest in getting out and working with commercial customers straight away when you develop the first product, to then roll something out into the ecosystem. It's more like, oh, our governments and our country wants to become more sovereign capable, and our space agency doesn't want to build that capability like ISRO or anybody else, and let us have our industry build that for us, and we'll procure that from the industry, right? So it's a interesting way of building things, but I'm not a very big fan of just governments doing all of this to it's a circulation of tax money that you end up having to do at the end, which is you'll never create companies that are billions of dollars that way if you keep circulating taxpayer money. Of course, you can always keep circulating billions of taxpayer money and you'll create billions of dollars worth of companies at the end. But yeah, that's again kind of unsustainable at the end. So yeah, I mean, this is all very interesting, because at the end of the day, we also keep looking at all of this, right? And a lot of people do complain that, oh, India, we need to have more of the support from the government and everything. And, when you kind of assess, a lot of these things, then you kind of feel like, okay, you know what, it's very easy that people can either die in 3 or 4 years trying to do something, or, they come out to become quite big. So it's a much easier path to take then. And because the ecosystem kind of forces you to go in that direction, perhaps, you are better off as a company, as the journey of the entrepreneur is actually better that way at the end. So, kind of moving on in here, what about talent? I know that you guys have, of course, you come from this Team Indus background, and you know each other, and you know what the industry trends are like based on your experience. Are there reasonably good talent available for you guys to say that we can, go hire somebody here and get them on board and they'll be immediately productive in whatever they want to do then? Or is it I was hearing, one of the other companies that I also advise in India tell me that they had on an average 1,500 applications per position that they broadcasted. So people who are applying to that job, and they had 5 or 6 positions, and they said that the same person applied to all 5 roles in many cases. So I was just, this is one of the things that I see as a signal to noise problem in the country at the end. So I was just wondering, what you guys think, especially in what you do. I don't think so. There's a lot of the people who fit into maybe what you are trying to do, and there's a lot of training and getting them onto speed to really be productive, right? So I would love to hear from you guys.
I mean, immediately, if I could say, on a slightly different note, I think we've got some tremendous talent. It's just that ultimately, if you do first principles thinking, you have a problem statement probably closer to something which is again a physics problem. And out of say 10 people, you find at least 1 or 2 people who do think that way, and who can given a thought, we don't need to instruct them. You can have these people taking off initiatives on their own and actually build something which is towards a direction that we would like. So I think that, say, for example, on the computer vision side, on the embedded side, we've got some great folks. A lot of the great folks are currently in Indian ecosystem. I've noticed that they're working in service companies. So many of them are not really building products. On the geospatial side, on the space side, a lot of them have gone to either ISRO or abroad for their masters. And I've noticed that many of the work, much of the work that is being done, we are not really building our own, say, NV software or say a PCI Geomatica, in which you really need to know each step of the way what's really happening in from the say satellite processing. If the first company that makes such a software comes in, that would be probably my great sign that okay, you've got talent which is particularly focusing on these aspects as well, where we understand the technology through and through. And I see that we companies who are fresh into the ecosystem, who are just compelled by the need of the business, have to build such things. Probably maybe 10, 15 years down the line, this is the same talent that might be building that. From the time point of view, I think we are at least 10, 15 years behind in taking such initiatives. It's just my experience. But the talent and the capacity is for sure there. It's just that those ideas, I would love to see, people from our kin and say in the aerospace ecosystem who are, having companies here, promote such endeavors where we could also make similar contributions to say open source space software analysis. And this is something that I feel that it's just a matter of time rather than that can it be simply possible in India now or not.
Great. And, what about funding? Now that in the last 2 or 3 years is what I see as this VC Series A capital being available in the country. So I guess you guys are also in the middle of this, where perhaps access to capital is today much more easier than 2 or 3 years before, especially when it comes to like VC money at the end. So was it like, do you foresee this as a right move at the right time because the right capital available is available today? Or?
Probably. I think it is certainly the right time because as in we know that it took a while for a sufficient amount of visibility to be associated with a Indian space startup. And I think all of us would agree that Pixel has started that. And that visibility also brought out a sort of insecurity, I think, amongst the investment fraternity in India, which is if we are not on that deal, which deal should we be on? So I think that is certainly something that is good and probably fortunate. But I don't think that is taken away any of the difficulty in conveying messages because we started with a great idea and we thought it was great. Then the next job is to convince them that it is great. And as we spoke about, the Indian ecosystem is not easy to communicate something that they don't natively understand, right? So you're still speaking to those who are like how do you say it, as a mobile app that could say make anybody a retail chain. You could do billing, you could do everything. As in, they come from the economics of scale from there, and probably try to find which is the closest correlation between what you're speaking and say a SaaS startup. And for us, fortunately, the way we wanted to position ourselves is ultimately this should be a SaaS offering. And if it has to be a SaaS offering, how do you really communicate this to them? Because they're going to look at it this way, that you're going to do a sort of intense NRE, and after that, distribution sort of happens on its own, exponential gains, and then you just have to think, is this whole thing, the scaling part, going to take care of itself, or do you need more money into that? So even there, you don't really fit in, even though you're trying to tell this probably might be a SaaS offering. So that's the place where, even though it's space, we found ourselves to be somewhere in between. Like we don't really have the sexy appeal of building a satellite. We're not building a rocket. We're not building a satellite. We're also trying to be down to the earth because we need to give people information that they need. They need to pay for it. They need to monetize that further, and they need to see value there. So what we saw is the trend certainly was there. But many times we almost second guessed that the next question that they're going to ask is, so how big is the satellite that you're building? Okay, is there a rocket involved? So that's where the trend that came with I think the investments around Pixel. So that picked up. The anticipation was that we have a really sexy satellite or rocket there, and then we tried to bring them down, and then they were like, "Oh, okay, you don't have a satellite." So, I think that was something that we saw that we were not exactly going with the winds of change. But what we also saw is we got a good support from the ecosystem outside India as well, where they saw that if you're trying to uh, simplify space for somebody who just needs numbers and integrate that with their own business process, this is something that's a real force multiplier. So we were able to get these really early stage investors both in India and outside, and they are sort of support through that early phase and actually building a team, understanding the market dynamics, and spending time. That was quite helpful, and it did come at the right time. And even despite COVID, I think that's been pushing us forward. So because their belief is the first thing, and their belief is not coming from a typical space background. So none of our early stage investors have put money in any space company. They don't understand that well enough, and when we speak to them, also it's real world stuff. It's not about when are you flying on a satellite. What they're asking is, have you been able to discover what is it that gets your customers sold? uh, have you been able to break it down for them such that they understand it as well as we have understood? So that's quite a good start to our journey that we've seen.
Great. And a couple of other topics that are again interesting is this whole policy stuff. From what you guys are building, I think it doesn't really affect you so much as the other companies would be, either operating launch vehicles or building satellites of their own. I mean, in this sense, do you see any specific requirements that you would want to change for your business? But I don't really see that. Maybe because you're processing some data, you're only on the data processing side. You're not really operating a camera. You're not really putting together a full satellite. You're not really looking to access to particular frequencies. So it seems that you are very well covered with your ground in terms of not really requiring any changes in policy when it comes to operating as a company.
I think this is Vishesh's favorite subject.
Couple of points here. So, a couple of aspects of the remote sensing policy of 2011 and 2020 do come in here. So, in the recent policy, if you see 0.5 meters or better resolutions are classified as sensitive. So, if anything is sensitive in India, then probably you should stay away from it. So it just is an immediate no. So the rate at which we are going, would probably like to operate sub-meter satellite images as well. And that would be something that would be requiring. I mean, so we haven't gone through this whole process where any sub-meter resolutions satellites images analytics I have to share with somebody. But probably this will be something that will come up. But on the same side, I also see the a little bit of comedy here, given the fact that the 2011 policy talked about resolution, sub-meter resolutions as sensitives and requiring NRSC approvals, and but you got Google Maps giving you 30 centimeter resolution data, and you can happily look at, say, in near barracks and plenty of places where it's kind of promised that things will be scrubbed off, and turns out that NRSC doesn't do that, and Google happily puts away all of this information for free. So if these either do away with all these clauses, or at least have a very efficient way to vet this and enforce a policy, I would love to have that part implemented. Probably, with the private players informed and kept in loop of so that essentially informs really what kind of products we could work with in the near future as well. And so this is something these are certain visibilities that would be great to have. But yeah, I think, apart from that, we are not having any obstructions with say with launch, or say something of that sort that other companies are facing. Sure.
I'd like to add on this. So a primary aspect which we want to demonstrate with our first flight, which we should be able to announce publicly in a bit, is the ability to say reduce the raw sensor data into something that is usable, right? And we're catering to these geospatial companies who probably have algorithms that run on analysis ready, really clean georeferenced pixels. So the intent is to make that available. And the question basically is that if they ask to say apply an algorithm on this location, they are not going to give it, say, through email or anything that is going to be human readable. Most of these companies want to automate even their own processes. And if they want to, say, fetch information that lies within a restricted area within their country or anybody else's country, all of that needs to be programmatic. So probably through an API, which is machine readable. And any policy that can be integrated into this would be great, but it needs to exist in sort of a software defined mode, so that if you wanted to, say, put a breaker in that saying that pixels 1 to n fall within a restricted area A, reject or drop this request. And it would be really great, because today what you're actually having is commercial players, if they want to sell imagery, say, into India, they need to go via NRSC, because this machine compliant process doesn't exist. So it's pretty manual, and it's also arbitrary, right? Because if you want to give the benefits of autonomy to someone, they are looking for repeatable delivery times. So you can't be promising someone you'll get a daily refresh of your change detection, but that could have a lag of anywhere between 1 week and 1 month. So really, it sort of spoils it. So what I'm trying to say is, even though we are not wanting to demonstrate that as a very crucial part, but that's going to come very quickly, because if you prove that you could get analytics done very close to the edge, then the next step is how do you automate it? And it could be accidental that a customer of our own partners end up querying, say, a Air Force base in Batinda or somewhere, and they should not be getting those pixels. So, but they either never get it, or they get it and somebody gets into trouble and they start justifying themselves because it's sort of ad hoc policy. So I feel, especially the remote sensing policy, it's great. As in, if they tell it's all great, fine, but they still tell it has to come via NRSC to be scrubbed. Really, we should move away from hard disks and CDs and emails. So that's what we expect would really help us, because otherwise, then we really limit an Indian market, and limiting the Indian market is not great for building the ecosystem.
Yeah, great. I think there's a number of listeners, of course, who are taking notes on all of this, and I'm gonna try to bring this up to some of the people that I'm working with in pushing some of these changes as well. I mean, things are kind of frustrating because there's no open consultation in general, and people are kind of making up rules as they go behind closed doors and not really consulting or having open consultations where they can learn what is the real requirement that drives commercial sustainability for people at the end. And this is something that we're trying to fix in the process as well. Yeah, I mean, let's see how things go, but I'm kind of hopeful that since the critical mass of people are there now, perhaps there's going to be a more open dialogue in moving all of this further in that sense. So what is the next 1 or 2 years looking like? What are the immediate milestones, and where do you see all of this moving in the next 12 to 18 months?
Yeah, so I think the first is, of course, to get our tech ready and demonstrate that in space. All our efforts are towards that, and feedback from that would really be great, because we want to share that with more satellite operators who may want to have this on their satellites. So first is that to share the benefits that they can get, and of course the next is to be able to probably give a few demo data sets that people can play around with, and once that is good to go, then probably we would put out a platform that you could go request for analytics of say like an app, apply this app on these locations and give me a result. So that's what we've set ourselves as sort of 3 steps over the coming 2 years, and beyond that, it's mostly to scale this up to meet demand. So in addition to just commercial demand, we feel it's an ecosystem that's built by those who use these data sets, and we are engaging quite a few of them to come in and think of how you could leverage these types of technologies to bring true value. Because I think like most of the market projections that tell the Earth observation value added services market is 3 billion, 4 billion. It's going to reach 11 billion in, I don't know, 1-digit years, 2-digit years. I think all of that is based on really seeing how much of a new user segment you could add every year. And a lot of it is based on the price point. A lot of it is based on complexity reduction. I think that's our main push, which is to take some of this ecosystem along with us, and some network effects, of course, will make that more popular. I think being one among very few companies trying to do this, especially in this region of the world, there's a very, very large diversity in problem statements that can be solved. And I think more of these companies might come up. And in an ideal sense, 2 years from now, if we have a company that is able to justify their own value proposition because they're using edge compute on some satellite in space, I think that would be a very great place to be. And we basically want to enable a lot more businesses to utilize Earth observation the way so GPS has spurred Swiggy, Zomato, Ola, all these guys. So if that is possible, I think that's sort of a midterm goal. If we can get there probably in 5 years and start actually making that mark in the first 2 years.
Yeah, if I could add, I see this as 2 parts here on the technology and the service side. So I feel that at least the next 1 year is critical for us to back up and demonstrate the technology that we are claiming to be building. And generally, the test will come when the real information is processed. And currently, we can talk about all the information that is available openly, but I think there'll be a lot of learning before we mature, let's say, our onboard imaging pipeline, and ultimately getting towards a place where we could start our service. So that anybody can walk in and actually give us a task which could be run on board, and do it totally seamlessly. It should be that level of maturity that we are trying to build over the next 1.5 years. And once that is there, and we look at not just one but multiple payloads, I would love to imagine this as a sensor agnostic and a platform agnostic platform, as in by a satellite platform agnostic edge computing device. So that allows us the opportunity to not just be diverse in terms of global coverage revisits, but also diverse in terms of the kind of data that we want to process. Also be diverse in the kind of data sets in which we could fuse information together. I think so. In our roadmap, we would basically want to graduate from the existing multispectral sensors. So we will be wanting to include other sensors, which make sense. Uh, uh, Ultimately, I would like to, if I could give a real long-term thing from my point of view, is something that using geospatial remote sensing technologies, can we allow ourselves to be becoming someone who can verify uh, truth really on the earth. So say, for example, somebody wants to find out that, okay, is this particular thing true? If it's possible to view it, and if it's possible to have a reproducible evidence for the same, uh, this technology should probably take us there. And uh, I see that from the problem statements that exist today, we should be opening up rather than for just for data itself. I would like to see people using insights, and the volume of insights that the people are operating today should be 10x or 100x over the coming years.
Right. Thank you for that. And thank you so much for spending the time here. Final question. If people want to contact you in one way or the other, either to partner with you or so on, what would be like the profile of the people that you would want to attract contacting you, either potential customers or even otherwise other sort of people as well?
We would love to be associated with immediately geospatial companies who would like to onboard the algorithms and test it on a near real time, or say onboard computing system. Uh, as much use cases as possible would be perfect. We want to be very open, and so the initial resolutions are medium resolutions. That's something that we are targeting. So we would love to have use cases that companies are building. Yeah, so that, I think, from my point of view, would be the initial set of people we would like to target. But as we prove capacity, we would like to target a more generic end customer. So Aditya, if you want to add.
Yeah, so in addition to geospatial companies, of course, we are looking for those who are either building their own sensors, and they're trying to say collect more data than a platform that they could get a ride on can actually bring down. So, say most of these places that we've seen is the resolution is high. Tasking is probably the only way that you're going to recover the investment to put this in space. So those are certainly places where reducing the bandwidth would help. So sort of selectively downlink images that are useful. You're tasking them, which means the denominator in this equation is pretty small. The margins are really, really low. So you don't want to retask unnecessarily. So some of these will certainly help. Of course, hyperspectral imaging sensors are another phenomenon that has sort of started off in the last 3 years. So a lot of commercial companies are starting up with these sensors. So we'd like to speak to them to know what's their specific problem statement, because that's more technical, that goes closer to their own instrument, the way it works, ability to clean and contextualize the outputs. That's something that we really want to work towards, because that helps solve not just their problem, but it also solves it sort of in a more permanent sense, right? Because their sensor now not just comes with data, but it also comes with a little bit of like a tiny human being sitting there and telling, this is useful, this is not useful. You could send this in a different way so that you can be more efficient. So that's something that we're looking to speak to. And of course, satellite operators who probably have the whole ground station problem statement. If they're scaling up, they might be interested. And yeah, I think it's a theme throughout wherever we've reached out. Most of the companies are that we speak to are at max probably 5 years old. And I think it speaks to the revolution that's happening in the sector. So we called NewSpace the ones that came up in 2010. Now you already sort of have 2 cohorts of NewSpace in that time, and the third cohort is where we are. and they're trying to capture market from the first and second cohort. So I think it's the openness. So the really young companies are ones that are yet to face those problems that we would probably solve. It's the second cohort, which is 2015 onwards, those companies that actually are now realizing we don't want to be carrying the weight of resource requirements that companies that started in 2010 and 2005 had. But also, we cannot risk getting into new technology areas that sort of distract us. So they are looking for somebody outside, and we want to be the ones that can give them an entry point over here. So most of our work with these partners has been to understand their problem statement, deliver a demonstration for them, and we're also graduating them for sort of almost so-called free, which is to demonstrate it real time in space, which few people have access to. Show them that it's possible. Now, if you're able to monetize it, so be it, because that's when our first dollar starts coming in. So that's the amount of trust we see that's required in the ecosystem, and we are upfront to say that we'll work with you and try to solve your specific problem, because it's sort of like a three point triangle here, right? So we are in a place where we could give benefits to a lot of people. We've started with one, which is sort of the user side, and the other support pillars are, of course, who's the imager or the sensor, who's supporting you on board, who's the platform. We see like this sort of ecosystem can get a lot more benefits as we go along.
Thank you very much, Aditya and Vishesh. I think this has been a very interesting conversation to know, you guys progressing really well. I wish you, of course, all the best, and with your initial tests, as well as then hopefully scaling up with all the things. And I do hope that there's a lot of intertwining like mechanisms in place for many of the local companies, especially these other new space startups, to find traction with you guys. And, that could be something that be built out locally with some of this as well. Thank you again for spending so much of your time with this podcast, and, wish you luck.
Great. Thank you, NP. And as a person who's listened to some of your podcasts, it's a great privilege to be on one of them. So thank you for giving us some time.
I just want to give a last parting message on my end. Indian programmers, please get into computer vision and get into space. We want more of you. Do geospatial analysis, and there are plenty of opportunities coming up.